Elliot, have a seat at your desk. 1.7 in triangle. Get them both?
Yeah.
Okay, on your whiteboard, what I would like to see is this. I would like you to please draw a right triangle. This is going to be 5 centimeters, 4 centimeters, 6 centimeters, and I want you to give me the area of this shape. Then, on the same whiteboard, please do this one.
What were the areas of the top?
Oh, I'm sorry. 4, 5, and 6. And then on this one, this is not a right triangle. And I would like you to show me the area for that one also. Now, can somebody explain to me why I'm having you do this, Logan?
So for when the big state test comes up.
Well, okay, it's not just for the big state test. Why are you writing it on the whiteboard?
Because it's a lesson. We'll need it
Well,
someday
it's a
in life.
lesson. Someday in your life you might need it, but what else?
Some might.
Wait, missing 3
So
or
you can
5.
check it.
It is 9-3, let me enlarge that. It is a 9, sorry, this is 3, 8, 4, and 6. Let me enlarge it just a tad so you can see it. Harrison, you got your whiteboard out?
Yeah, I got my whiteboard, but
You marker?
yes.
Somebody help him. Donated markers to me, so it'd be nice if he actually had one.
I'm not the only one you have.
All right, hustle it up. Did you get one?
Yeah. Oh, yeah, make it a little bit different.
Here.
Finish.
This one. Right triangle, it's 4 centimeters, 6 centimeters, and 5 centimeters. Just do that one. Okay, and switch your chair, please. I can't get your fingers out in the breeze. Can somebody else give Joaquin an extra whiteboard marker, please?
He can use mine right after.
Well, I need him to have one.
Okay.
Here. Have one?
Got one.
Thank you. Okay, all right, Emron, work it out if you can. Try to figure out what the area is. The whole idea is I am trying to figure out, because nobody actually told me why we're doing this. Why am I having you do this? Okay. Okay, so Miss Rickard can look at this, but no, that's not the whole reason. Have I taught you how to do the area of a triangle yet?
Yes.
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 I tippy-toed into it, but we didn't teach you how to do the area of a triangle.
We're teaching you yourself.
What I am trying to do right now
See what we know.
is to figure out what you know. And to see, there's 2 of them up there, Steph, you get the other one too. And to see if you have any idea how to find the area of a triangle. Now, I did give you a pre-test when we started this unit. And do you remember out of 14, what did I say was the most anybody got right?
2.
Well, almost. 3. 3. I had one person get 3 right, and 2 people got 2 correct. Okay? So let's just say that out of 14,
We did not do
you didn't do great, and you need me. Okay?
less than great.
But that's okay, because so far as I'm walking around here, I am seeing, I'm walking around here and I am seeing that nobody has the area of a triangle correct.
Wait.
Okay, I lied, there's one person that has it correct. Oh, okay, did he show, okay, let me see. Almost with one exception. You see what I'm talking about, right? Okay, so now, put your whiteboards in your desk, we're not using them, do not erase them, because when we're finished, we're gonna pull them out and see if you have any idea now how to solve it, and why there are only 1 and basically a half kid in here got them right. And you'll see later what I mean by 1 and a half kids.
Who are those children?
Okay, we are in 1.7. Joaquin, hustle it up, dude. Put it on the top. 1.7 area of a triangle. Would you please read the I can statement for us, Jackson?
It's kind of hard to see the board. If you need to scooch it,
Okay, so find the special relationship between a pair of identical triangles and parallelograms. Show me with your arms parallel, please. Parallel, not perpendicular. Parallel means that, like railroad tracks, they never touch. Perpendicular does what?
T.
Makes a T, right? Makes a right angle. Okay, then we are skipping 1.8 because I looked at the lesson last night and it was dumb, so we're skipping 1.8. Let's go to 1.9. Would you please read the first I can statement on 1.9, Aubrey?
I can use the area formula to find the area of the triangle.
Do you remember I told you when we started this area unit that I could probably teach you how to do these lessons in 42 seconds?
Yeah.
And why did it take 42 seconds and not 30 seconds?
Wait.
Probably
Because
because
you
I,
have to re-explain.
probably because I had to explain it again because somebody wasn't listening, right?
Yep.
These things are super easy to explain, so I can teach it to you like that.
Please.
The problem is, and what I found out, is that I have not been giving kids enough hands-on time to do stuff, and that's why I really like this Open Up Resources, because you know how they have the online thing where you can click and drag and do stuff?
Yeah.
And that, I think, is going to make a difference. Okay, I don't want you, don't start clicking around on things, Ariston. All right, we are now looking at, let me see, look at the third one. Would you read the 1.9, the third one, please, Jenny? I can write one.
I can write and explain the formula for the area of the triangle.
Okay, area of a triangle. What I did notice is that not one of you wrote the area of a triangle on your, no, you did not. You thought you did, but you did not. You did not write the area of a triangle formula on your whiteboard. Okay, and what is the third one, please? Logan, go ahead.
I know what the terms base and height refer to in a triangle.
Okay, and then we will get to 1.10, but it is super duper simple. It says I can identify corresponding pairs of bases and heights in any triangle. Okay, I'll explain what those words even mean later, don't worry about it. Okay, now, if you would, go into, I believe,
Yeah, the top one.
is it the top right one?
Yeah.
Okay, this top right one is how to change from a parallelogram to a triangle. What's the formula to find the area of a parallelogram? Base times height. Area equals base times height. A equals B times H. It's the top one, right? No, it's the, it should be 7.1.
Yeah.
Okay, well, we're getting there. Hold on. Okay, so if I know that you can do this, what would I do to find 7.1? What would I do to find this?
You would do multiply the H and
I multiply the H and the B, and there we got it. Okay, there is, now don't you go to anything, hold on 2 seconds in Windows, I gotta make sure. All right, do you see this one that says IM 6.1.7?
Yeah.
Super secret code? Open that. This is the GeoGebra.
Oh.
Now, get opened in that one. This is the one we attempted to log into the other day, and you remember how well that was. We got it eventually. We got it, but it wasn't necessarily pretty. Okay, fingers crossed. Did you get into it? Is GeoGebra open on everybody's?
Yeah.
Okay, can you brighten your screen up just a tad, please? And GeoGebra open. He's not been on it before. I just know we opened it.
No,
but
he
we haven't
has.
seen it.
Because
Oh, is
last
he?
time you guys.
Oh, yeah, you already logged on. Okay, so, you are in GeoGebra, or however you say that, because that's just a word, you're not in GeoGebra. Bottom left-hand one, 1.7. Thank you, Ron. Okay, now let's go ahead and go through. Take a look at the slides first. You don't have to do anything on them, I just want you to take a look at them. Just scroll through it. There's some questions, okay, and there's some activities and things we're going to do. All right, now go back to the top one. And I have Okay. Do you remember I kind of dissed on the Mr. Morgan guy when I looked at it and went, oh dear God, it's 28 minutes?
Yeah.
Somebody shoot me, I'm not doing this.
Yeah.
Okay, well, so last night, at 10:30, when I'm staring at the screen you're on right now, and I went, I don't know how to answer this. I don't know what I'm doing. I thought, oh dear Lord, I gotta go into Mr. Morgan. Mr. Morgan, here we come.
Yeah.
Okay,
Wait,
here's the
I
thing.
need you to aim.
Don't worry about it.
8th grade.
Perfect, open that one.
I know,
Thank you, Ms. Rickert. Okay, so we are going to, you are not clicking on this. This is for the benefit of those whippersnappers that are not here today.
See, but is it a parallelogram?
Okay, hang on, don't
Nope.
do that.
We have
Wait, why?
one fifth.
It's not,
All right, so
because,
first off,
keep in
here.
mind, you saw where it was? You know why it was already being played?
You watched
Because
it?
I watched it at 10:30 last night to figure out what in the heck I was supposed to do. As Mr. Morgan goes through this, you are going to do this on your screens as well. You got it? All right, so pay attention to Mr. Morgan. Now
There are
here's what
two
he's talking
copies
about.
of a parallelogram. Each copy has one side labeled as the base and a segment drawn for its corresponding height and labeled H. So it's the same parallelogram, but they've labeled a different base and different height. The base of the parallelogram on the left is 2.4. So we'll just label that real quick. This is the base length of 2.4 centimeters. And its corresponding height
You guys
is
need to be writing
1
this on
centimeter.
yours. And if you need
Find
to-
its area in square centimeters.
Yeah.
So it's
Click on
important that you
the-
label that real
You go
quick
down, look at
because now we have a
Look
base.
at the bottom where you can
we
have
have
a
a
toolbar.
height.
There's
and
a
now we're going to
scribble.
take the base times
See
the
the scribble
height
bar?
to give us our area. So our base in this case,
Everybody check your neighbor and make sure they know how to write on their screen. Elliot, they got it?
Yeah, I got it.
Oh, yeah, you.
Okay, Joaquin, you got it? Yes? What?
No, it has to load. It has to load.
No, my triangle thing's like straight.
Okay, can you please brighten this up so that a human being that is 57 years old can actually see your screen? Okay. Because you were- Oh, is anybody, oh, there it is. I think if you lose it, click on the thing on the left that says lesson 6.17 or whatever. Because somehow Joaquin found the magic button that disappeared things. All right, so everybody should be writing what this guy is writing. You good?
Yo,
It says
and
two.
if you need to write that down, it's like right below it. It's like,
Yeah, you
Oh,
have
write
to
your
go.
answer here.
Okay, you see the scribble?
Yeah.
Okay, that's what you're going to be writing. All right.
0.4. Alright, and we'll multiply that by the height, which
Because
is
they
1.
told us,
So we have an area of simply 2.4 centimeters squared.
because didn't they already say that the base is 2.4 and the height is 1?
Yeah.
Okay, it flat out says it. It's written down next to number 1. Okay?
It says centimeters all the way along. No problem. Now, in
Get the
number
one that
2,
belongs to
it
H.
does tell us here
Get
that
one
the
that belongs
height
to
of the
H.
parallelogram on the right is 2 centimeters. So this height right here is 2
Where is yours? Get to it
centimeters.
so I can see it.
Great. How long is the base of that parallelogram? And explain your reasoning. So the question there is, how long is
If you need
that?
to move so you can see,
So,
please do.
what we've noticed before is that again, because these are copies, right? It's a copy. They're going to have the same exact area. Now the area of this one was what? We said
See it.
before, the area of this one was 2.4. That's the area of that shape. Which means this one also has an area of 2.4 centimeters squared, right?
I'm a little embarrassed to admit that when I looked at this, I kind of completely forgot everything I had taught you about using a formula and solving it algebraically, which is why I was like, I don't know how to do this.
I was just thinking,
Were you?
I have no idea.
And I was like, oh my God, I'm like, I can't teach this. I don't even know what I'm doing. I'm supposed to be evaluating tomorrow. I was like panicking, okay? You know, because watch how he does this. And he did it and I was like, oh, maybe I don't hate Mr. Morgan
That's just how it's
anymore.
going to be. So,
Maybe.
if I have a base times the height
This is on number
equals
2
an
now.
area, and I've already been given the area is 2.4,
See what he's doing?
and I've been given a height of 2. What I haven't been given is the
Go down.
length of that base. But
That's-
I can figure that out by getting the B isolated here.
Okay, guys and ladies, do you notice that on your GeoGebra, you did this top one, right? And you know the squiggles are down here. scroll down, he puts another one of them, the exact same one is down below it.
Oh.
This is the one he's working on now,
Oh.
because, do you see how it says here, there are 2 copies? What does a copy mean?
Same exact
It's
thing.
identical, it's congruent, it's identical. Each copy has one side label, and then it says here, look at the information at the bottom. They are, so we already know if they are identical, what is the area of this parallelogram?
The same.
Which is 2.4 centimeters squared, right?
Yeah.
All right, so if we know that, then let's continue, and now you can see where he got it, because I literally stared at this one, I don't have it, I don't get it. And then I'm like, oh, now I get it. Let me make it larger again so you can all see it.
Here, so I'm going to divide both sides by 2.
Okay. What do we know is the height? Well, I'm going to back it up. I want you to listen again as to how he figured out. Okay, where did I see height? You see next under number 2 it says the height is 2 centimeters.
Yeah.
Okay, and we know what the total is. So what do I do to get the variable? What do I do to get b by itself? What do I have to do to get the variable by itself?
Divide by 2.
Divide by 2. Don't I have to get rid of this times 2?
Yeah.
Yeah.
What's the opposite of times 2?
Divide.
Divide by 2. So I divide by 2 on both sides. Let me back it up a tad just so you can see it.
It's 2.4, and I've been given a height of 2. What I haven't been given is the length of that base, but I can figure that out by getting the b isolated here. So I'm going to divide both sides by 2. Right, 2 over 2 is 1, so I'm just left with just the b. So the base is equal to 2.4 divided by 2. Right, if you use a calculator, it would work. If I did 2.4 divided by 2 long way, I could do it like this. And 2 goes into 2 one time. 1 times 2 is 2, so we're 0. I put my decimal right up there right away. So bring down the 4. 2 goes into 4 2 times. 2 times 2 is 4, with 0 left over. So the base in this case will be 1.2. And I can put that up there as a note. The reason I know that's the case is because, again, if I was to multiply this out to double check,
And did you see
if
what
I
he did with that
1.2,
decimal? It comes
the
straight up,
base
right?
Times the height, which is 2. 1.2 times 2. Well, you end up with 2 times 2 is 4. 2 times 1 is 2. 1 decimal, 1 decimal, 2.4. And that's the area I was looking for all along. Right? So it works out just fine. If I have an unknown,
So if there's an unknown, you do exactly what you've already been doing with me with algebra. Solve for what you know, fill in the blanks, and divide it. And because I was looking at it, you remember my approach was, I'm looking at it going, well, wait, it's almost the same length as this, and so maybe if no, that's not how you do it. Because you can't just guess in order to get it. Yes, sir.
Can you open up Splash Top, because I think I might want to share screen.
You know what, if you don't mind today, I don't want to because it's the evaluation, but if I was doing this, we need to practice to make sure that Splashtop still lets me go into GeoGebra. So how about you and me practice it, okay?
Okay.
All right, and I apologize because it is kind of dark, isn't it? And I don't think there's any way to lighten it up.
Yeah, but
one unknown of
I'll come up and
measurement,
help you.
you can find the other one without a major problem there. Let's look
Okay.
at
You
activated
can turn
Scroll
the
down
quality
now.
up. You can turn the quality up.
It's
and
called
you can see
Table
it
of
better.
Two Triangles. It's part 1 here.
This is a good
It
thing.
says
This is
2
what I'm learning.
polygons are
Is what
identical
I need to be able
if
to
they
do.
match up exactly
in
when
this one.
placed one
Yeah.
on top of the
Scroll
other.
down, it's there.
Draw one
Does it
line
look like that?
to
Yes.
decompose, that is break apart, each of the following polygons into 2 identical triangles if possible. That's a big thing, if possible. Use a straight edge to draw
Scroll
your
down,
line.
get your
So let's take a look at the first one here.
Scroll down,
The
get your
idea is,
scribble
can
tool.
I
He's
draw a
using
straight
roller 'cause
line
he's
from
very efficient.
corner to corner,
Don't worry about it.
make a triangle that would be identical? Alright, so there's our shape there. And the question is that going to be an identical triangle?
yeah.
Play with that. Well, let's take a look with some patty paper real quick and see what you come up with. If I draw a line to follow that pattern, follow that pattern, and follow that
And he
pattern.
flips it
And
around.
take that and spin it around.
And is it
Match
identical?
it perfectly.
There you go. So you can divide that square into
two
two
identical triangles
equal
right there.
triangles, yes?
Okay, let's take a look at B. B, I'm gonna do the same thing. I'm gonna go from a vertex to a vertex in order to make a
Very good, you got it
triangle.
already. See if you can work ahead, if you can figure out how to split them in
Here.
triangles.
And
They
when I
have
do
to be
that, I
identical
end up
triangles,
with
so be
two
careful.
identical triangles.
There's a couple
Let's
fake
take a
ones
look.
on there for you.
But does that have to be
Go
from
right
the
here.
Okay.
Have a line to there.
Now, what I am noticing is, do you see that on this, I'm looking at Sam's screen right now. Sam, what did you do on B? Because you are correct. What did you do on B? How did you split it in half? You went side to side. Which way did this guy split it? Up and down. But do you still have two identical?
It deleted what I had.
Okay, don't worry about that. We're not on that one anyway. Okay, can you split it sideways or straight up and down? Yes. There's two different ways you can split it. Just because he split it that way doesn't mean it's the only right way.
There. Have a line right there. Oops, a little curvy, sorry. And we have a line right
He
here.
does not know curves.
So this is my triangle that I drew.
See me working.
Let's see if that triangle then would line up with this one. So far, I'm like, oh, not quite. Well, let's keep twisting. No, not quite. Keep twisting, and look at that.
Does that
There
make
it
sense?
is. That works just
Okay.
fine, doesn't it? So that's going to work, isn't it? How about C? Well, C's a little different, right? We notice it's a
Anybody notice the
quadrilateral,
problem
but
with
is
C?
it a parallelogram?
Yeah.
Harrison, you doing
It's
okay
not
over
a
there?
parallelogram, is it? This line follows a horizontal grid line.
Harrison,
This
is
one
that
does
X
not.
mean it doesn't work?
This one follows the vertical, this one does not. So let's see what happens. I'm going to go ahead and draw another, we'll make a triangle here. Let's go across this way. It doesn't matter, you could have gone a different way, but go vertex to vertex so we make a triangle.
Show me with your hands, what is a vertex?
It's
What does
a
it mean?
corner.
It's the
It's
part
the
in
corner, right? It's the peace sign, it's the corner, vertex. You can't just go to the
When you
middle
make
of
that
it.
triangle, are those two parts going to be equal? And you can see just visually, the answer is going to be no, they're not equal, right? You just draw one real quick. Let's just trace this one right here. So if I trace this one with a patty paper and try to match that on top of that, it's just not going to fit. No matter what I do, I'm not going to be able to get it there. It's just too small. So this one's not going to make two identical triangles, is it? So I'm going to just kind of put a box around that and just say, nope, not going to work for that one. How about D? D looks like it'll probably have more success. It's a little bit like the square shape up there. So we'll go from a vertex to a...
Okay, how many of you think you can do D?
Already did.
Did you do D? Okay, how many of you think you can do F? What is this? F. Wait, was this G? Which one is this? E. Can you do this trapezoid?
No.
Okay, somebody says no, somebody says yes.
No, you can't.
All right, we got a question then on this one. What about F, this parallelogram?
Yes.
Yeah? Ken, what about this rhombus?
Yeah.
Okay, so really the only one you've got a question about is going to be F. So if you don't mind,
Vertex once
as
again.
much, E, whatever it is.
Push
As
it
much
around
as I
C.
love this guy, we're
We'll
speeding him up.
parallelogram.
Okay.
Nope, we have one pair of parallel lines,
Okay.
but these ones
Watch
are
this
not.
one because this one's a
So there's
fake out.
trapezoid, but not a parallelogram. Let's try to connect the vertices just to make the.
Why is it not a parallelogram? What are the requirements to be a parallelogram?
Straight.
Elliot.
All the sides parallel to each other have to have the same length.
Correct. The sides next to each other have to have the exact same length, and the opposite sides have to be parallel. In this case, the opposite sides are not parallel. Nice job. Elliot, go get a pride pass. Good work.
So we'll go there, and we'll go there, and we'll go like this. And let's see if we can rotate that around a little bit and make it
See,
match.
look at what's going on with this. Does that
man,
match?
just not quite, huh?
There's no
Right, you
way
can see
to
actually,
make a trapezoid
it
do
does
that.
fill up that whole space, but we actually have a whole extra piece right there, don't we? We have a whole extra bit that doesn't quite make it. It's a little bit too large, so it doesn't work for E. F is a parallelogram again. It's quadrilateral parallelogram. Let's see if we can make this one work. I'll go vertex to vertex this way. You could do the other one if you chose. That'd be fine. All right? And again, that's gonna match just fine. I'm gonna do this one real quick here. We're gonna go to the little vertice or the little space. And again, it's parallelogram. If you trace those out, you'll see they work as well. Okay. So, which quadrilaterals can be decomposed, broken apart into two identical triangles? Alright, which ones would work? We would say A, and B, not C, D, F, and G.
Okay, are you writing that down at
So
the
we're going to
bottom?
study those quadrilaterals,
Okay. All right, we're moving on.
parallel lines.
Okay,
A, B, D, F.
okay. What he's doing at the bottom is he's trying to say, he's writing down the ones that have two identicals. In other words, he's writing down the ones we didn't scribble out. Big deal, don't worry about it. Okay, study the quadrilaterals. They can be decomposed into two identical triangles, but then he wants you to take a look at what you notice about them. One, the ones that you could do are parallelograms. The example Elliot just gave us. They are quadrilaterals. What does quadrilateral mean? Four sides. And they have two sets of parallel lines, which is exactly what Elliot had mentioned. All right, let's go to the next one. On this one, you are to draw two identical triangles on your next section. So quickly scroll down and draw two identical
you can
triangles.
use the polygon thing. It's like a tool.
Is there a tool that does that? Well, then
yeah.
you know more than I do.
Yeah.
Okay, good. Then congratulations, you're gonna have to try and draw a straight line with your skill set.
Okay, never
Come on,
mind.
scroll down.
Never mind.
Scroll down.
You just click it and then you can.
Oh yeah, when you click it, you make the dots. Click it and make the dots.
It's that triangle. I have a better idea. I use
Mine looks horrible.
Okay, Kaden, did you figure out how to make the dots connected? Come over here and help Joaquin get them. Please.
No, it looks messed up.
Okay, somehow or another, when you click on those, you can click and drag. All right. Now, I don't even know, do they have one that you can copy?
Yep.
Can you do a copy paste?
Tiny one. Like this?
Okay, here's one, let me show something, Tina. All right, Tina's done this one, her triangle like this. Now, hers is going to be a little more difficult to see if she got it identical. Wouldn't it be easier if you actually used the grid lines
Yeah.
and made a right triangle?
I think you should make that.
Okay, if you make a right triangle, then you can just count the little squares, and it's easy to make an identical one. When you go sideways, now you're trying to count the sideways slanties. You can do it, but personally, I would prefer that it had a copy and paste. All right, let's go on.
4, I can hide the 4. So I'll make that my starting point and go out.
Do you see how what he
That's the key
did?
thing. We're connecting the two opposite vertices of a parallelogram, and it's going to work out.
Okay, so in drawing the thing, now he wanted some quadrilaterals, basically that you can divide. So if you did two triangles, couldn't you hook those two triangles together to get a quadrilateral, aka probably a parallelogram? Okay, moving him on, let's go down to the tail of two triangles. Is that one the next one? Which one says this? Go down to the one on your screen that looks like, it says new pair.
There's like two.
I made two identical
Okay.
triangles.
Okay, good. Scroll
Exactly.
down your screen. Sam, scroll down your screen, honey, because I can't see where I'm at. Okay. All right. What this does is you can click on the yellow to move it, and you can spin it with the green.